Good day, grade 10s. How are you guys doing today? Welcome to this chemistry lesson. This is Marshall A.C. Candiado. Today we're going to be looking at empirical formulas. We are still under the main topic, stoichiometry and the Mole concept. So today we're going to be looking at the empirical formula. And the objectives for today's lesson are as follows. We must, by the end of this lesson, be able to define the term empirical formula, deduce empirical formula masses from molecular formula, compare empirical formula masses with molecular masses. I will also just want to put in that from the work from the previous exercise, from the previous lesson, you guys did well for those who submitted, Maria and Tuna. The rest of you, I don't know what you're doing and what your business is about because I didn't get the work. Right, so I hope if you still know where the work is, that you submit the work so that I can see where you stand. But for those who wrote, the calculations were, as I indicated in my responses, that they are very simple. Right, they are very simple. But now we want to move on to this concept of empirical formula. So I hope you got a chance during the weekend to just read a bit about what empirical formula is. So that's what we're going to be looking at today. Okay, so the empirical formula, this is a very, all these concepts at the moment are very simple. There will be others which I know will be a bit challenging, but this one is extremely simple. This is the simplest formula which indicates the simplest whole number ratio for a molecule. So if you are given a molecule, I'll give an example. I'll show this video soon. Where we have something like hydrazine, something like that hydrazine, in fact. So when you're given a molecule like hydrazine, this one which is N2H4, you will find that this molecule has more than one nitrogen atom. It has more than one hydrogen atom. And when you are given these compounds or molecules, when you want to find the empirical formula, all you're doing is you are just looking for the simplest whole number ratio of the atoms found in a given compound. So if you are given a compound and let's say there is a compound known as hydrogen peroxide, right? So this compound known as hydrogen peroxide has the formula H2O2. H2O2. You can tell that and you can see that it has two hydrogens and two oxygens, which means that if you were asked to write it to its simplest whole number ratio, you just divide both the hydrogen and the oxygen by 2, and it will just end up being H1O1, and it will just be HO, right? But effectively, it's H2O2. It's H2O2, right? But the other thing to note now with the empirical formula is that it doesn't then tell you if you're only given a compound and this compound is only having the empirical formula, you won't actually be able to know what the actual number of atoms present in the molecule is. Because if I say, let's look just quickly here at the empirical formula, which has CH2 here and then C2H4. Just from this one, CH2, which is the simplest formula, you can't then know what the actual compound, the number of atoms it's having. But I think it's important that we just watch. There's a short video that I'm going to play that is explaining rather clearly also how to come about with this empirical formula. So let's watch this
Hydrazine. Its molecular formula is N2H4. But its empirical formula is NH2. The molecular formula of a compound tells us two things. One, the types of atom in the molecule, in this case nitrogen and hydrogen, and two, how many types of each atom. In this case there are 2 nitrogen atoms and 4 hydrogen atoms. The empirical formula of a compound also tells us two things. One, the types of atoms in the molecule, in this case nitrogen and hydrogen, and 2, the simplest ratio of each type of atom.
the simplest ratio of each type of atom, right? So if we look at this one for the molecular formula tells us how many of each type of atom is there. So you're going to have to know the relationship between the molecular formula and the empirical formula. So the molecular formula will tell us the types of atoms that are in the molecule and how many of each type of these atoms is present. Whereas the empirical formula will show us the types of molecule also, the types of atoms that are in the molecule also, but it will only give us the simplest ratio. Look at this one, NH2, right? If you don't know what this, the structure of this compound of hydrazine looks like, you won't actually know to say, so this hydrazine, how many nitrogens is it having? How many hydrogens is it having? Okay? So you can just pause the video for now and just compare by yourself the molecular formula and the empirical formula.
The ratio of nitrogen to hydrogen in hydrazine is 2 to 4, making the simplest ratio 1 to 2. The best way to find the empirical formula from percentage composition by mass is to go over a question. Upon analysis, the percentage composition by mass of a compound was found.
Right, so let me stop it a bit here. You find that in our notes. I then ended up adding a part about percentage composition of a compound. You'll find that in your living chemistry or your, what's the other one? The solid foundations. They didn't add this information, right, at this level. But it is critical that we know this information of the percentage composition of a compound, right? But before we go there, right, so you can then be able now to compare the empirical formula and the molecular formula. You just see that when moment you're given a molecular formula, it's very simple for you to change it to the empirical formula. You just find the simplest whole number ratio. Look at H2O. There is nothing you can change either on iodine pentoxide. There is nothing you can change on iodine pentoxide because it's already, you can't simplify it further, 2 and 5, right? There isn't going to be a common denominator that you're going to find there which allows you to simplify further. If you look at this one, such as the glucose molecule, this one, C6H12O6, if you divide throughout by 6, you find what? The simplest formula ratio there, and that is the empirical formula.
Found to be 8 percentage composition by mass is to go over a question. Upon analysis, the percentage composition by mass of a compound was found to be 87.5% nitrogen and 12.5% hydrogen. Now calculate the empirical formula. Firstly, we have a column for each element. N for nitrogen and H for hydrogen. Then, under each element, we put the percentage composition by mass. So that's 87.5% for nitrogen and 12.5% for hydrogen. We then divide these percentages by the relative atomic mass of each element. So that's...
I hope you're still following. What has been given here is what we would call, it's just an abstract. It's an abstract situation where you have nitrogen. In another question, the nitrogen could have been maybe 45% and the hydrogen could have been that. But here in this case, the nitrogen is 87.5%, and for you to get to 100, you're then left with 12.5. But what is important is how you get to divide by the relative atomic mass. That's the important part that we must follow it step by step. Please try to follow it step by step.
14 for nitrogen and 1 for hydrogen. Doing this calculation gives us 6.25 for nitrogen and 12.5 for hydrogen. We then divide these numbers by the smallest of the two, which is 6.25, and this gives us the ratio of 1 to 2. 1 and 2 is the smallest possible ratio.
observe in this particular case that we are talking about a situation where you have just been given that this is the empirical formula of hydrazine. You have not seen this structure. You don't know, right? Right now you are thinking, why are they telling us this? Because I already know that hydrazine has 2 nitrogens and 4 hydrogens. We are saying if you are given this table, and it only has empirical formulas and there are no molecular formulas, you should be in a position to be able to say what is the molecular formula, right? And how do I find the molecular formula? Okay? How do I find the molecular formula? What ratio was used to simplify for me to end up with NH2, right? So that's how you're going to proceed with this particular calculation.
So, the empirical formula is NH2. But how do we find the molecular formula? The molecular mass for this compound is 32. The molecular formula is the empirical formula times.
The molecular mass will be given also. The molecular mass, you will be given the molecular mass because it won't be possible for you to calculate it without knowing what the molecular mass is.
N, where N is the number by which we have to multiply the empirical formula in order to get the molecular formula. I have coined the phrase empirical mass to describe the mass of the empirical formula. So in this case, we have nitrogen, which is 14, plus hydrogen, which is 2, giving us 16. Now, just as the molecular formula is the empirical formula times N, the molecular mass is the empirical mass times N. So, molecular mass of 32 is N times the empirical mass, 16. Therefore, N is 32 divided by 16, or 2. So now, molecular formula is the empirical formula times N. So that's NH2 times N, or NH2 times 2, which gives us N2H4.
N2H4. N2H4. So what you guys will do, because this is just something that I'm putting in, because it's information that I feel that in chemistry it's required. It's required even at grade 10, and I'm pretty sure that next year in grade 11 I'm still going to have to repeat this material. So for now, just try to chew it slowly. Don't choke on it. Say, now why are we being given all this difficult material? No, just go over it, right, so that you can have an understanding. So I said, in your textbook you won't find it, but it's relevant material. So I put an example of a calculation such as that one, where I just asked you to calculate the percentage composition of all the elements. This one is a case where you are given a certain mass, right? You get the mass from when you say calcium carbonate. If you can add the masses, if you add the mass of calcium and that of carbon and that of those 3 oxygen atoms, you'll find that they all add up to 100 grams. So for you to find the percentage composition, all you are doing is then going to say the mass of calcium over the overall mass of calcium carbonate. The same thing you're going to do for ammonium nitrate. For ammonium nitrate, what you're going to do is you're going to find the overall mass of this NH4NO3, then you'd start saying how many nitrogens are there, right? So you have 2 nitrogens, what is the atomic mass of nitrogen? You find the atomic mass of nitrogen, and then you divide it by the molecular mass of this one, and it tells you what the percentage composition of each of those individual atoms is, right? So that's just something to just also push us to the next level, right? Because that's what we want. We don't want to be staying at the same level that we are at right now. We need to be improving continuously. The empirical formulas of these ones, you can try them by yourself. These ones, this is where I am on the screen, right? The empirical formulas of these ones, you can just try them by yourself as well, and then we'll just discuss them, and we'll discuss effectively all of this material again in the WhatsApp lesson. So for now, I hope that we've managed to cover the objectives that we set out to cover at the beginning of the lesson. Thank you very much, guys, for paying attention. Make sure that you watch the video, once, and just try to perfect that. Thank you very much.